Hi everyone, this is Nicole with Titans of CNC Academy, and in this video I'm going to show you how to program the TITAN-9M for the Tormach. To begin, we need to set up our stock. So to do that, I'm going to come up to Setup, down to New Setup, and I want to change our orientation to select Z-axis plane and X-axis. I'm going to select this top face as our Z-axis, and I'm just going to zoom out. And now I can see my origin, and I'm going to choose that for my X-axis. The next thing I want to do is change our origin to model box point, and then I'm going to select the back left edge of our part. Next, in our stock tab, I want to change our stock offset mode to add stock to all sides. So you can see that our part size is 6 inches, and I know my stock size is 6.1. So I'm going to add 0.05. 2x, and our part depth is 1.9 inches, and I know my stock is 2 inches, so I'm going to add 0.05 to y, and I'm going to do 0.23 for our negative z offset, and for our positive I'm going to do 0.02. So it should read 6.1 by 2 by 1. I'm going to go ahead and click OK. Now that we've set up our stock, we're going to go ahead and rough out our part. Now normally we would do a face pass like we've done on the rest of the parts in this series, but because this doesn't really have like a large face area on top, I'm going to go ahead and just cut straight to the 3D adaptive toolpath to rough out our part. And instead of wasting the time with the tool change just for this little strip of material on top, we're actually going to go ahead and just finish that during our 3D surfacing later. So we're going to come up to 3D and down to adaptive clearing, and we're going to choose the tool from our library. We're going to be using the 1/2 inch end mill. So we're going to be running this at 4,000 RPM, and we're going to do a cutting feed rate of 25 inches per minute. I'm going to do 25 for our leads. For our ramp and our plunge, I'm going to go ahead and set it to 15 just to be safe. In our geometry tab, I don't really need to select anything. I am going to uncheck rest machining since we haven't cut anything yet. Rest machining basically calculates what's been done in the previous tool paths and goes from there. We haven't done anything, so I'm just going to turn it off. In our heights tab, I want to change everything to model top. And our bottom height offset is going to be negative 0.77. All right, and in our passes tab, I want to go ahead and check the box that says machine shallow areas. This will allow the tool to get into these more shallow areas that are closer to the top of our stock, and that'll just leave less for our finishing tool paths to clean up. All right, and our minimum shallow step down looks good. I like the numbers that are in there. Maximum shallow step over, that's a good number. For our optimal load, I'm going to change that to 0.025. Our maximum roughing step down, I'm going to change to 0.8. And I'm going to check the box that says flat area detection. This will allow the toolpath to detect these flats on our part and machine it at that level. For our stock to leave, I'm actually going to leave 0.01. This will leave enough material for our 3D surfacing tool paths to clean up, and it'll be a nice finish when it's done. I also want to check the box that says order by area. This will help organize where the tool focuses on during this operation. In our linking tab, I'm going to change our retraction policy to minimum retraction. I'm going to set our maximum stay down distance to 10 inches. And I'm going to change our stay down level to 70%. Our non-engagement feed rate, I'm going to change to 90 inches per minute. And for our helix, I'm going to change our ramping angle to 1 degree, our taper angle 1 degree. I'm going to also change our minimum ramp diameter to 0.45. And then I'll go ahead and click OK. So you can see that the tool is going to ramp down in these center pockets. That looks really good. It's going to slowly work its way out, doing both levels of that counter bore. It's going to come up and start roughing out our 3D surface in here. And then it's going to come around and it's going to walk around the outside of our part, roughing out that outer profile. to do is finish the outer profile of our part. So to do that, I'm going to come up to 2D and down to contour. We're going to use that same end mill. I'm going to slow it down a little bit. This is a finishing pass, so I'll do 20 inches per minute. In our geometry tab, I want to select the outer profile of our part. And in the heights tab, I want to change everything to model top. And our bottom height offset is going to be -0.77. In our passes tab, I want to set our compensation type to wear. And we can go ahead and add a finish overlap of 0.01. In our linking tab, I don't really need to change anything in here. We can go ahead and add an entry position. We'll just make it this front left edge. This way we can see the tool when it's coming down, and we'll have a really good view of where it's starting on this part. I'll go ahead and click OK. So you can see the tool is going to come in. It's got its lead in. It's going to walk around the part, finishing that outer profile. Do is finish this hole here. So to do that, I'm actually going to duplicate that last tool path, and I'm going to edit the new one. Really the only thing I'm going to be changing in here is our geometry selection. I'm going to remove the current contour, and I'm just going to select the bottom contour of our hole. In our heights, everything is already correct. Our passes tab, I don't need to change anything. That looks good. And in our linking tab, the only thing I'm really going to change is I'm going to remove that entry position, and then I'll click OK. So you can see the tool is going to drop down. It's going to come around this hole. Tool's going to come back up. That looks great. So now we need to finish this counter bore in the center of our part. So I'm going to go ahead and duplicate that last tool path, and I'm going to edit the new one. This time I'm going to change the geometry to the contour of our counter bore. And in our heights tab, I want to change it from model top for our bottom height to selection, and we're going to select the bottom face of our counter bore. And I want to go ahead and remove our offset. So I'm going to set that to 0. Our passes tab can all be the same. That looks fine. In our linking tab, I don't need to change anything. I'm just going to go ahead and click OK. Tool's going to drop down just the same. It's going to come around the bottom of our counter bore, finish that surface. So now the next thing we need to do is start our 3D surfacing. So before we do that, there's a couple things we have to do. So I want to 3D surface this area here, but I also want it to do over these holes so that it'll be a nice clean blend after we drill and chamfer these holes. So what we have to do essentially is to patch these holes, and of course there's many ways to do it, but a quick easy way that'll be easy to toggle on and off is just to patch them. So I'm going to show you how to do that. We're going to come up to where it says manufacture up here. We want to drop down to design. So when you're in design, you'll see that we have some menu items up at the top here. We have tools, sheet metal, mesh, form, and surface, and solid. So right now it defaults to solid. We want to be in surface. In here, we can actually create a patch to cover those holes. So we're going to drop down create, and we're going to choose patch. And we're just going to select the outer diameter of our hole where the chamfer is. and that's going to cover it up, and I'm just going to click OK. Now you'll see they actually do have a shortcut up here under the Create tab. We don't have to drop it down, we can just click that, and that will open Patch, and then we can go ahead and select the next hole and click OK. And then we've got 2 more. We're going to click Patch, select our hole, click OK, Patch, hole, OK. So now that we have those holes patched, you can actually see that it created separate bodies. So these are not actually connected to this body. You can verify that by opening your Bodies tab, and you can see all of these additional bodies we just added. So now that we've done that, we can come up to the Design tab again and drop back down to Manufacture. And now that we're in here, we actually have to add those to our setup. So right now, the way it is, none of the toolpaths will recognize those as part of this setup until we add them, since we haven't already. So I'm going to right click on our setup, and I'm just going to go to Edit. And you can see here that under Model, it actually has our body, our main body selected, but we want to include the 4 we just created. So I'm going to close this one so that you can see me select them. And then I'm going to select each one at a time. All right, so now it says we have 4 bodies selected, and now I can choose this main body again, and you'll see all 5 are selected. Now we can click OK, and now it will recognize those as part of our model. So now that we've made changes to our setup, we actually have to go and regenerate our toolpaths that we already created. So I'm just going to right click our setup and click Generate, and it'll regenerate all of those. Okay, so now we can go ahead and finish this flat surface. So to do that, I'm going to come up to 3D, and you can see we have several different toolpath options here for ball tracking or 3D surfacing. In this particular case, since we're doing a flat surface, I'm going to choose horizontal, and we're just going to select the tool from the library. We're going to be using the 1/2 inch ball mill. Go ahead and click OK. All right, we're going to be running this at 4,000 RPM, and I'm going to do 25 inches per minute. Now in our Geometry tab, I want to go ahead and select this surface, but just this surface. I don't want the whole entire part. So you can see when I highlight this chain, it's kind of selecting this whole profile, and I don't want that. And you can see when I mouse over this line how it changes, and it actually is selecting a different contour now. So what you can do is sometimes you can mouse around until you find the contour you're looking for. Like in this case, I just found it. That's the exact contour I wanted to select. So I'm going to go ahead and choose that. See, that's not the one I want. Perfect. All right, so now that I have my contour selected for each side, I want to go ahead and make sure my tool containment is set to on center. And I'm going to change my additional offset to 0. In our Heights tab, I want to change everything to Model Top. And then our bottom height is going to be set to Selection, and I'm just going to choose the face that we're going to be surfacing. In our Passes tab, I want to make sure I check the box that says Manual Step Over. And I'm going to set our maximum step over to 5 thou. The reason for such a small step over is the finer step over we go, the smoother the surface is going to be. Obviously, I don't want to spend all day working on this part, so I'm going to set it at 5 thou, and that'll give us a nice smooth finish. All right, in our Linking tab, I'm going to go ahead and change our retraction policy to minimum retraction. I'm going to set our safe distance to 0.1, and our maximum stay down distance is going to be set to 5 inches. We can go ahead and change our ramp type to plunge, since we're going to be plunging off the material, not going to start it on the material. It's going to start off and work its way in. So I'm going to set that to plunge. I'm going to do our ramp clearance height. I'll do 0.03, and then I'll go ahead and click OK. So you can see how the tool is going to start off the material. It's going to walk into the center and it's going to start working its way out, finishing this whole face. That looks perfect. And with a lot of 3D surfacing tool paths, you want the tool to come off the part quite a bit. We're going to be adding a chamfer around this part later, so I'm not too worried about it. Plus, if you look really close, our tool actually does just slightly come off of the model. You can see that the tool is going to start off the part on this side as well. It's going to walk into the center, start working its way out, finishing this whole flat surface. That's perfect. So now the next thing we need to do is finish this contoured surface here. So to do that, we're going to come up to the 3D tab, and this time we're actually going to use a parallel toolpath to do this. I'm going to be using that same 1/2" ball mill, same feeds and speeds in our geometry tab. So I want to select this top surface all the way down to the flats where we already started on. But as you can see, it kind of just selects the outer profile or like these pockets. I can't really get it to select just this top surface. So I'm going to show you how. First, I want to change our machining boundary to selection. And I'm just going to start by selecting the top contour of our part. And you can see it created this contour here. I'm just going to select that contour that it created. And you can see it gave us some more options here. So if you look close, you'll see this thicker black line. That's where it thinks that I want it to select. But I'm just going to tell it, I want you to actually turn here. So I'm going to select this line. That's where I want it to stop. And then I'm going to do the same thing. I want you to turn here. Perfect. So it's going to come around that corner. You can see it actually figured it out for this side. And now we have to do the same thing on the opposite side. So right now it thinks I want it to come here. I'm going to tell it actually turn here and turn here. Perfect. So it figured that one out. So I can go ahead and hit the plus symbol and that'll create my contour. All right, that looks great. Now we only want it to do this surface. I don't want it to do in the air here. So I'm going to select this inner contour here, and that'll keep the tool within this boundary. So that's perfect. Now, just like the last one, I want my tool containment set to center. And then in our heights tab, I'm going to change everything to model top. And then for our bottom height, I'm actually going to leave it to model bottom. I want it below the surface that the tool is going to be working on. Since this is a 3D toolpath, the tool is going to know where the bottom of the toolpath is. I don't have to tell it since it's 3D. It can actually read the model. But I do want to make sure that our bottom height is set below that area. So I'm going to actually bump it up a little. I'm going to put it at 0.3. It's still below our surface, but it's raised up a little bit just in case. That looks really good. So next in our passes tab, I'm going to change our step over to 5 thou. That'll be a nice, consistent, clean, smooth surface when we're done. In our linking tab, I'm going to change our retraction policy to minimum retraction, and our maximum stay down distance I'm going to set to 10 inches. I'm going to go ahead and click OK. Then you can see that nice, clean toolpath. That looks super good. The tool is going to come down. It's just going to start walking back and forth across our part, finishing that surface. The next thing we need to do is finish these 3D pockets. So to do that, I'm going to come up to 3D, and we're actually going to be using scallop for this particular surface. So I'm going to be using the same ball mill. I'm going to change our speeds. I'm going to go 20 inches per minute. We'll just go a little slower. It's going to be down in that pocket. I think that'll be good. For our geometry, I'm going to set our machining boundary to selection, and I'm going to choose the top contour of our pockets. All right, perfect. That looks great. So again, we want our tool containment set to center, and that looks good. Next, in our heights tab, I want to change everything to model top, and I'm just going to leave our bottom height set to model bottom. In our passes tab, I want to change our inside-outside direction. We definitely want it to be going from the outside in. We're not going to start in the center and work our way out. It'll be easier on the tool to just kind of slowly walk down into this pocket. So that looks good. We again want to set our step over to 5 thou. And then in our linking tab, I'm going to change our maximum stay down distance to 10 inches. And then I'll go ahead and click OK. So you can see the tool is going to start here. It's going to walk around the top edge of our chamfer here. And then each pass it takes around, it's just going to take a step down. And it's just going to keep walking all the way to the center of our part. So that looks really good. It's going to come up and do the same thing on this side. It's going to walk around our part, slowly walking down into the center. to do now that we've finished all of our 3D surfacing is work on these counter bores. To start out, I'm going to actually turn off those patches that are covering those holes. So I'm going to open up our models tab here, and you can see that it shows us the model. I'm going to go ahead and expand that as well. And you can see bodies here. I want to open that one. I'm just going to turn off all 4 of those. I can go ahead and collapse that just to get it out of the way. Now we can go ahead and start working on our counter bores. So I'm going to start by spot drilling them. I'm going to come up to drilling, select drill. I'm going to choose the tool from our library. We're going to be using the 3/8 chamfer mill. I'm going to go ahead and run this at 20 inches per minute. In our geometry tab, I'm going to go ahead and select each of our holes. And in our heights tab, I'm going to change everything to model top. And then our bottom height, I'm going to set that to selection. I'm just going to choose this face here. And I'm going to just drop it down -0.1 for our bottom height offset. All right, that looks great. It's just going to be spot drilling our holes. In our cycle tab, I'm going to make sure it says drilling rapid out, and I'll go ahead and click OK. You can see the tool is just going to drop down. It's going to spot drill each of our holes. It's going to come up and over. Next, we're going to go ahead and drill this. So I'm going to come up to drilling, select drill again. I'm going to select a tool from our library. This time we're going to be using the 1/4 inch drill. And I am going to go ahead and run that at 4,000 RPM at 18 inches per minute. That's perfect. In our geometry tab, I'm going to go ahead and select all 4 of our holes again. And in our heights tab, I'm going to do all model top. And we know that our part is 0.750, so I'm going to go -0.750. And we can see that gets the tip to the bottom, but we want the tip to go all the way through, so I'm going to do drill tip through bottom. And we actually want it to go past a little bit, so I'm just going to add a breakthrough depth of 0.1. All right, that looks perfect. In our cycle tab, I'm going to change our cycle type to chip breaking with a partial retract. I'm going to do a pecking depth of 0.075. I'm going to do our minimum pecking depth. We'll do 0.015. Our accumulated, I'm going to set that to 1 inch. We don't want it to do any full retract, so it's just going to peck all the way down. And our chip break distance is going to be 0.01. And I'm going to go ahead and click OK. All right, that looks great. So then the next thing we need to do is open up our counter bore. So to do that, I'm going to come up to 2D and down to Pocket. And we're going to choose from the building blocks library the 1/4 inch end mill. Right there. And I'm going to be running this at 4,000 RPM with 15 inches per minute. In our geometry tab, I want to select the bottom contour of each of our counter bore. And in our heights tab, I'm going to change everything to model top. And then our bottom height will be set to selection, and I'll just choose that bottom face of our counter bore. In our passes tab, I'm going to go ahead and change our maximum step over to 0.02. And I'll set our stock to leave. I'll do 5 thou. In our linking tab, I'm going to go ahead and we want to make sure that this box is checked here for keep tool down. Otherwise, it's not going to start in the center of our holes. So just double check that that's checked. We can go ahead and actually turn off our leads because we're just going to come straight down and it's going to start spiraling out. And I'm going to go ahead and set our ramp type to plunge. We have to make sure that we set our pre-drill positions. I'm just going to go ahead and select each of our holes. Perfect, now we can click OK. So you can see how the tool is going to drop down and start spiraling out. Opening up these counterbores. It's going to come up over our part and do these two as well. Now we need to finish those counterbores. So I'm going to go ahead and do a 2D contour. We're going to use that same end mill, same feeds and speeds. I'm going to go ahead and leave that. Inner geometry tab. We need to go ahead and select the contours for our counterbore again. And in our heights tab, I want to change everything to model top. And then our bottom height will be set to selection, and I'll go ahead and do the same base. There we go, on the bottom of our counterbore. In our passes tab, so I'm going to set our compensation type to wear. Anytime we're doing a finishing operation, it's best to set this to wear so that we can control the compensation of our tool right at the machine so that we can dial in our numbers as we go. So I'm going to set that to wear. This all looks good. In our linking tab, I want to go ahead and change our safe distance to 5 thou. It's a real tight space, so we're just going to use some tight numbers. Our leads are going to be set to 0.01. Perfect, that looks great. I'm going to go ahead and click OK. All right, so you can see the tool's going to drop down. You can see our tiny little lead in there. It's going to walk around our counterbore, finishing that surface, and then it's going to come back up and do the other 3. Now the last thing we need to do is chamfer our part. So instead of using a regular 2D chamfer, which won't recognize these changes in height on our chamfer, we're going to go ahead and use under 2D trace. And so we're going to select the tool. We already have the tool out under our part. We're going to be using that 3/8 chamfer mill. So I'm going to choose that. And I'm going to change our feeds to 20 inches per minute. I'm just going to go ahead and change all of these to 20. Perfect, and then in our geometry tab, I want to select the top contour of each of our chamfers. So I'm going to start with the main body chamfer. I'm going to select the chamfer on our counterbores. I'll do this center one. And these two over here. And then in our heights tab, I'm going to go ahead and change everything to model top. In our passes tab, I want to change our sideways comp to left or climb milling. I also want to add a chamfer tip offset of 0.04, and you'll see it actually adds an axial offset of 0.04. I'm going to go ahead and set that to 0. And then in our linking tab, I'm going to go ahead and turn on our lead in and our lead out. And then I'm going to go ahead and click OK. All right, perfect. So you can see the tool is going to drop down here. We've got that offset in there, so it's not going to be right on the tip of the tool. Okay, so the programming for this part is now complete. I hope you enjoyed this video. Thank you for watching.